a cation. When an atom gains, it carries a negative charge and is called anion. All right. Now, matter can also be divided into two. We have got pure substances and we have got mixtures. Mixtures can also be classified into two. We have the homogeneous mixtures and we have the what heterogeneous mixtures. All right. Now we go on. Elements, pure substances can also be what divided into two, and that is elements, and we have compound. When we go further, elements can also be divided into three: metals, metalloids, non-metals. I want you to get in this thing very well. All right. So let's continue. Yeah, today we're continuing with the particle model of matter, and our objectives are by the end of the lesson you should be able to state the three states of matter. You should be able to define the density of a substance. You should be able to identify substances with different densities. You should be able to identify pressure. You should be able to identify and explain reactants and products from a chemical equation. You should also be able to explain some properties of matter, understand the concept of what the particle model of matter as we did yesterday. So it's just a continuation. All right, so we're going to look at the states of matter. You remember we said matter is anything that has weight and can occupy space last time. Then matter can also be what? Can occur or can exist in three states. So matter occurs in one of these three states. We can talk of the solid, liquid, or gas, depending on the temperature. Now, guys, listen. The state of matter depends on its melting point, which can be abbreviated MP, and boiling point abbreviated BP. If the temperature is below the melting point, then the substance is said to be a solid. But if the temperature is above the melting point, but below the boiling point, then the substance is said to be a liquid. And if the temperature is above the boiling point, then the substance is said to be a gas. All right. Okay, so let's go on. Change of state. Now, a substance can change its state. It can be from solid to liquid and to gas, or from gas to liquid and to solid, or from gas to solid straight away. Okay. Now, heating and cooling can cause a material to change state. We shall see that in the following diagrams. The solid material first changes to a liquid that is melting when it is heated, and then it changes to a gas, that is when it is evaporating or boiling on further heating. Now, what happens is that the gas first changes to a liquid, which is called condensing when it's cooled, and then it changes to a solid when it's freezing or solidifying when cooled further. All right. Now, as a solid material is heated, the movement of the particles increases, which enables them to move past each other and form a liquid. You remember the particle model of matter. All right. All matter exists in particles. All right. So I repeat the bullet again. As a solid material is heated, the movement of particles increases, which enables them to move past each other and form a liquid. All right. The particles move much further apart from each other when the material changes from the liquid to the gas state. So as we saw the diagrams yesterday, you could see that solid, the particles, they were close. When you compare that to liquid, they were close, but not as close in terms of solid. And then when we came to gas, you saw that the space between the particles of the gas, they were even more further apart. All right. Okay. Now let's go on. Let's look at this diagram, change of state. Okay. From my far right, we have got what? Solid. Now you see that the particles are so close. Okay. Now when we apply heat the top arrow, it says melting. So when we apply a heat or an amount of heat to a solid, like say ice, then it becomes melting and it changes to liquid. Now, what happens is that as it changes to liquid and then we add further heat, then it will go toward evaporation. Then when it evaporates, then we say the liquid has changed to what? Gas, as you can see. So if you look at the particles of the gas, that of the liquid and that of the solid, you will be able to what see the differences. So here the particles are can move freely if they are in gases, a bit free in liquid, and not at all in solid. So they vibrate within their fixed position. Now we can go on the down arrow. So the inverse of heating will be what? Cooling. Now what happens is that if we have got these gas particles in the container we are seeing, then we start decreasing the temperature. Then the gas molecules or the vapor will tend to condense. So that process is called what? Condensation. Now, so the gas or vapor will condense and become a liquid or turns into a liquid. As we continue to decrease or move the heat, then the liquid start freezing or become solidifying to give us the what? The solid. So from the process whereby a gas turns into a liquid is called what? Condensation. And the process whereby a liquid turns to solid is called freezing. And the process whereby a solid uh, turns or changes to liquid is called melting. And the process whereby liquid turns to vapor or gas is called what? Evaporation, as we can see there. All right. Now let's go on. We still on change of state in order to melt ice. So as we just saw in the previous slide, we need to add energy to it to raise the temperature to melting point. However, if we want to freeze water, we need to remove, that is, take out energy from it until the temperature decreases to what? Freezing point. Now let's listen. Does boiling have a reverse process? Yeah, when we boiling a liquid, does it also have a reverse process? And the answer is yes. Boiling is when liquid water changes to water vapor or steam. The reverse process, when steam turns back to water, is called what? Condensation, as we saw in the previous slide. In order to boil water, we need to add energy to it. But if we want to condense the water vapor, we need to cool it down. That is, take energy out of it. All right. Okay, now we continue with boiling and evaporation. Boiling, the temperature at which a particular material changes from the liquid to the gas state boils. Or yeah, so the temperature at which a substance changes from the liquid to the gas state is known as what? Boiling. But as you move on, there is a definition which will slightly change from this one. Okay. There are some important differences between evaporation and then what? Boiling. So we are saying that when you boil, the water changes to what? Vapor. We are also saying that when evaporation, the liquid changes to what? Or the substance changes to what? Vapor. So what is the difference between what? Evaporation and boiling? Are they the same thing or they are different? We will get to know that. Evaporation can take place below the boiling point of a liquid. So you'd see evaporation can take place at any time below the boiling point of a liquid, but boiling takes place only once the liquid is heated and reaches its boiling point. So that is a very important difference you have to understand there. I repeat the fourth bullet. Evaporation can take place below the boiling point of a liquid. So if you have water outside, you place water outside and the sun is very hot, the water will start to evaporate even though it has not reached its what? Boiling point. But for boiling to occur, the liquid will have to be heated. It means you have to apply heat and the substance or the liquid or water will have to reach its boiling point. Until then, we can see the water is being boiled. And then when the gases escape or the water vapor escape. Now, we look at evaporation. Evaporation occurs at the surface of a liquid as individual particles gain enough energy to overcome the forces holding them in the liquid and become individual particles in the what gas state, as we can see from the previous slide. So solid, they were close; liquid, they were being separated bit by bit, but at the gaseous state, the particles were way far apart. Now, boiling occurs within the liquid. So we are saying is that when you have a liquid placed outside under the sun, evaporation will only take place at the surface of it. But what happens when we are talking of boiling? Boiling occurs throughout within the liquid, not only at the surface, at the bottom, in the middle, everything. Boiling occurs within the liquid so that enough particles escape in large quantities and form bubbles of gas in the liquid. These gas bubbles then rise to the surface of the liquid, and the liquid is said to what? Boil. So I hope you get some differences between what? Boiling and evaporation. All right. Now let's go on. There is this picture. I hope you see it clearly. It's just to uh, uh, consolidate what you have learned so far. Now, when do we say a solid, a substance or water is a solid? When water is a solid, it means the temperature is below what? 0 degrees. So you can see beneath there, you are seeing negative 100 degrees Celsius. So water at this level, so it means zero is even greater than negative 100 degrees Celsius. Yes. So what happens is that below 0 degrees, the water is solid, meaning the temperature is below 0 degrees. Now, what happens? Let's go to 0 degrees Celsius. So, in effect, at minus 100 degrees Celsius, the water is now a solid. But when the water is at what? 0 degrees Celsius, then the ice will begin to melt. So supposing we have a solid, is in the fridge, the water was in the fridge, it turns into solid. Probably the temperature was 100 degrees Celsius. Now, if you adjust the temperature, and the temperature then becomes what? 0 degrees Celsius, then the solid ice is now getting melted, which is the melting point. So the melting point of ice is what? 0 degrees Celsius. Now, if you manipulate the temperature again or the heat, and then you get to 100 degrees Celsius. So what is happening is that at 100 degrees Celsius, boiling point of water has been obtained. So simply the boiling point of water is what? At 100 degrees Celsius. And beyond 100 degrees Celsius and into 200 degrees Celsius, we say that the water is now a gas. So in summary, uh, the temperature below 0 degrees is a solid. The melting point, the temperature at which ice melts is 0 degrees. The temperature at which water boils is 100 degrees Celsius. The temperature at which water is a gas is beyond or above what? 100 degrees Celsius. Okay. All right. Now let's move on. We are continuing to understand or consolidate with this picture also. Now I have a beaker here, and inside the beaker I have what? Solid water that is equal to ice. Now what happens? What happens if the ice is going to change to liquid? Then it means it's going to what? Melt. Now melting is a what? Is a process which requires energy. So the ice will start melting if you apply a bit of energy in the form of heat. so heat energy. Then the ice will then what? Turn into liquid water. So it was solid water, which was called ice, is now liquid water. All right. Now the reverse process. So from water, we can change it to solid ice again by what? Freezing. So here we have to take the heat energy. So heat energy, we have to release the heat energy that was taken in or that was given into the what? Solid ice for it to melt. But on the other side, we have to take out. The heat will have to be released so that the liquid will change to what? Solid ice. Okay. Now we still continuing with the concept of the particle model of matter. Now all what we have seen in the various slides, the particle model of matter comes in. So we are saying atoms and molecules are referred to as particles in the what? Particle model of matter. So the solid particles, the liquid particles, the gaseous particles. So yesterday, as we said the particle model of matter is a scientific theory used to explain that all matter, solids, that is solids, liquid, and gases, is made up of what? Particles. And these particles are too small to see. And we said in a drop of water, there could be millions or billions of water particles. And then we said the spaces between the particles are empty. So as you can see, that of the gas and then the liquid. And then when what we saw in the solids, the spaces, there are no spaces, they are at a fixed place and they vibrate in their main position. Now, scientists have evidence that suggests that the particles are arranged differently in a solid, liquid, and a gas, as we can see. For solids, they are a bit compact. Then for liquids, they are not that compact, loosely compact, or they are loose compact. And then in gases, they are very loosely. They are very loose. Okay. So scientists have come out because of this particular model of matter to tell us or to suggest that this is how particles in the various three states of matter are, how they are arranged. Okay, now let's continue. Under this topic, we're supposed to know what density, mass, and volume. All right. Now, what is a density? The density of a material describes the amount of mass in a given volume of that material. Or in simple terms, we can say density is defined as the mass per unit volume of a substance. Okay. So what it means is that is mass, and then look at the volume. I'm indirectly trying to conceive the density of that substance. All right. So having known the density of what? The definition of density, let's look at the relationship between density and states of matter. In general, gases are less dense than liquids, and liquids are less dense than solids. So, for example, if I should uh, take a gas, let's say hydrogen gas, I blow it into a certain quantity. I blow a certain quantity into a balloon. Then it will feel light. Let's say I blow a quantity, let me just say 100 centimeter cube of air into it. All right. Then I take the same 100 centimeter cube of water volume into another container or the same balloon. Now, if I were to weigh them, you see that this one will be less, the hydrogen, but this one that is water will be a bit heavy because the density of liquid is more than water. So in general, gases have got less density, liquids have got more density compared to gases, and solids have even got more densities than liquids than in what? Solid. So in simple terms, solid is denser than liquid, liquid is denser than gas. Now let's look at density of different materials. Some materials have low density and some have what? High density. So for example, if I have a stone or a metallic material, then if I'm going to weigh it, if it is having the same mass of that solid and compared to the same of water, you will see that that one, the metallic metal will be very, very heavy. Or even, for example, we can even compare a paper, a single paper, a page, and then a book. So you will see that the book, depending on the type of textbook, if it is a very big textbook, you can see that it will be more heavy compared to what? A single paper. So some materials have low density and some have got high density. So for example, we can look at a loaf of bread has low density than a clay brick of the same. A brick of the same size as the loaf will have higher density, and then the loaf will have lower density because the solid is more compact as compared to what? The loaf. Now let's continue. The individual particles making up one material may have got what? Different masses compared to the individual particles making up a what? Another material. So if we can go back to the previous bullet, we say if we look at the brick and then look at the loaf of bread, if they are heavy or will have more mass, will have what? More density as compared to what? The loaf of bread. The loaf of bread will have less mass because the particles are not that close together. And if it is having low mass, it means it's going to have what? Low density. Okay, so let's go on. In addition, there are spaces between the what? The particles. We just mentioned that. I just mentioned that now. Then the density of a material will depend on the kind of particles it is made up of and the size of the spaces between them. So the substances or the particles that a substance is made of influences the density of it. All right. Now let's go on expansion and contraction. Expansion and contraction of materials. Solids, liquids, and gases tend to expand when heated and contract when cooled. We say solids, liquids, and gases tend to expand when heated and contract when cooled. Particles of liquids and gases are in a state of what? Constant motion. Remember, according to the particle model of matter, particles of liquids and gases are in a state of what? Constant motion. That cannot be said about what? Solids. Solids are in a fixed position. All right. Now, what happens? As a material is heated, our reference point here is liquid and gases. The movement of the particles increases and they move further apart. Therefore, the material expands. Now, you have to understand this sentence again. I'm reading it all again so that we can appreciate what we're talking about. We're saying particles of liquids and gases are in a state of what? Constant motion. Now, as the material is heated, what happens to the what? The particles? They gain more heat. And when they gain more heat, the movement of the particles increases and they move further apart. Therefore, we say the material expanded or has expanded or it expands. Now, material as a material is cooled, the movement of the particles decreases and they move closer together. Therefore, the material contracts. So what we're saying is that as we heat, the particles gain more energy and say the material or substance is expanding. But what happens when we remove the heat? When we remove the heat, what is going to happen is that the particles will lose energy. And when they lose energy, their movement will decrease. And when the movement decreases, they get closer to each other. And as they get closer to each other, then we say the material has contracted. Okay, now when a material expands or contracts, the size and number of particles does not change. Instead, it is only the spaces between the particles that get bigger or smaller. I repeat this, it's very interesting. When a material expands or contracts, the size and the number of particles does not change. Instead, it is only the spaces between the particles that get bigger or smaller. Now, let's look at an example. If you remember the previous slide, the vapor or the gases that was in the container, you saw that the spaces were more. Now, what happens is that if I heat, what is going to happen is that the spaces are going to be more further apart, but the gas particles will remain if it is, say, is helium gas particles. When I heat, nothing will happen to the particles themselves. They don't change. It's only the spaces between them that increases. Now, what happens is that if I apply heat, the spaces are even more. Then when the spaces are even more, we say the material has expanded. Now, what happens if I remove the heat? If I remove the heat, I'm simply decreasing the spaces between them. And when I decrease the spaces between them, here again, the particles of the helium are not changed. It's only the spaces that are decreased. And when the spaces become smaller, we then say, an example, what contracts. Now, during expansion, the spaces between the particles get bigger, as I've just said. And during contraction, the spaces between the particles get smaller. All right. Now, let's look at pressure. Pressure are a gas that exerts pressure because of the collision of the particles with each other and against the size of the container. Now, so let's look at this. Pumping more gas into a container increases the number of what gas particles in that container. This increases the number of collisions and therefore what so in simple terms, what is pressure? Pressure is the force per. Okay, now let's look at this. Football. Let's say you have a football match and then your so and then you go. You want to increase in number. And as hitting each other, they hit each other, the air particles will hit each other, and then they also hit the walls of the balls. And when they do so, we say pressure has increased. All right. Now I have got something for you. It's your turn now. I've been talking, so it's your turn now. So again, I want us to do it as we always do. Question one, we'll start with question one. All of you will send in your answers. Then we correct each other and we ask questions. Then after, we will go to what? Question two in that order until we are done. Okay. All right. So it's your turn now. So you may ask questions if you have, then we can go continue at the chat room. Okay, that's great. Okay, let's go to question two. Let's go to question two. Your answers are correct. Let's go to question two. Question two says, define the density of a what? A substance. So we are on question two. Okay, guys, let's go to question two. Question two is saying define the density of a substance. So you can explain it in your own words. Sorry. All right, keep your answers coming for number two before we go to number three, guys. The time is running up. Let's be fast. Guys, are you there? All right. So let's go to question three. Okay. All right, guys. Let's go to question four. The time is okay. Guys, let's go on. Yeah, I appreciate your answers. You have done well. Let's quickly go to the correction before I summarize. Our time um, is limited. All right. Now let's go to these are the answers, the corrections. So if you said write down the three states of matter: solid, liquid, and gas, that's correct. So those most of you got it correct. Two, define the density of a substance. So density is the mass per unit volume of a substance. Okay. Now question three, define pressure. Yeah, some of you were defining it in another way of which you were correct. So, but we can also say that pressure is the force what per unit area. All right. Now explain the following properties of what matter: boiling point and melting point. So we say boiling point is the temperature when liquid changes or turns to a gas or vapor. And melting point is the temperature at which a solid turns into a liquid. Question five was saying what is the melting point of ice is 0 degrees. And question six, what is the boiling point of water is 100 degrees Celsius. All right. Now we have been looking at the concept of particle uh, model of matter. All right. And we say atoms and molecules are referred to as particles in the particle model of matter. And then we said the particle model is a scientific theory used to explain that all matter, whether it's a solid, a gas, or a liquid, is made up of what? Particles. And then we are saying According to the particle model, if you look at a drop of water, then you can have millions or billions of water particles. Then the model is also telling us that we have got spaces between the particles, and those spaces are empty. And then scientists have also shown that there is evidence that suggests that the particles are arranged differently in solid, liquid, and gases. All right. That was just a summary of the lesson. So, in our next lesson tomorrow, we'll continue with the concept of the particle model of matter. And then I will just allow for one or two questions. Yeah, one or two questions. Then we call it a day. Yes, 100 degrees Celsius. Bye. I hope you guys enjoyed the lesson. If you didn't enjoy it, let me know so that I can always improve. See you tomorrow and share and enjoy the rest of your day.